Climate change poses a growing threat to cultural heritage sites across the United States. But science is helping land managers and communities protect important ancestral sites in a rapidly changing world. I'm Chilton Tippin, and I work at the North Central Climate Adaptation Science Center. I study how climate change intensifies drought and water disputes in the American Southwest and along the US-Mexico borderlands. In the course of doing this work, I've begun to notice how climate change is affecting not only wildlife, watersheds, and human societies, but a lot of ancestral heritage sites that are particularly meaningful to indigenous people of the region. The Las Conchas wildfire incinerated thousands of acres of ponderosa pine forests and destroyed ancestral heritage sites of spiritual significance to the Pueblo people of the Rio Grande. In the southeastern United States could drown as many as 13,000 cultural heritage sites. So whether it's erosion or wildfires, sea level rise, or melting glaciers, the threat climate change presents for ancestral heritage sites has major implications. For one, the archaeological record tells us the story of who we are, and it draws important lessons out of the past so that we can learn from them today. But even more importantly, descendant indigenous communities regard ancestral heritage sites as part of a living landscape that's really important for their tribal identities. As an example of this, I was part of a project at Canyons of the Ancients National Monument in the summer of 2025, and I learned that for the Pueblo, Ute, Apache, and Dene people who trace their lineage to this place, that the sites there are still inhabited by their ancestors. Canyons of the Ancients is located in southwest Colorado, and it has the highest concentration of cultural heritage sites anywhere in the continental United States. And since there are so many of these archaeological features clustered in such a small area, land managers and native people with ties to the region are faced with a growing challenge. They have to adapt the landscape so that it protects thousands of kivas, wickiups, room blocks, and stone towers, and other significant features from a multitude of threats, all of them related to climate change. And so to help inform these efforts, we did a study that uses climate models to understand the specific, localized impacts of climate change on the different habitats of the monument. We worked with an archaeologist from the monument to get a sense of which features could be especially vulnerable to threats like extreme rainfall, wildfires, and erosion. Then we used an archaeological database to figure out what kinds of habitats these vulnerable ancestral sites were located in. For example, we found that a lot of stone towers built by ancestral Puebloans were located in pinyon juniper forests. We know from the scientific literature that these forests are threatened by extreme heat and wildfire. So this means that the stone towers that are embedded in these pinyon juniper habitats are likely at risk of wildfire as well. So this is just one small example, but the bigger picture is that with this method, we can help managers and indigenous communities make land stewardship decisions to protect the cultural heritage sites. And they can do so in a way that is both sensitive to cultural priorities and informed by climate science. So science is helping us prepare for the future today. Learn more about climate adaptation at nccask.colorado.edu and follow us for more climate science stories.